Hello students, welcome to our last lesson. This is lesson 6 of unit 3 on transformations. It's about composition or composite transformations. Sometimes we also say multiple transformations. And what we're doing is we're doing a series of transformations, one after the other, and we're getting locations all throughout. So our end result, is the composite of all the ones prior. So here, let's just go through this worksheet, and that's pretty much it. You'll get a 2-for-1 on this one because this worksheet counts as both the lesson and as the worksheet that you'll submit for credit. So a point X has coordinates -1, -4. The point is reflected across the y-axis and then translated 4 units to the right and 6 units up. What is the new coordinates? So what are the new coordinates? So let's put X here. We'll say X is -1, -4. So X, which is -1, -4. And we are going to reflect across the y-axis. So let me draw that in. It's my line of reflection. The point is reflected across the y-axis, so that will put the point at x prime, which is 1, -4, because my x's changed because I flipped it across the line x equals 0, or the y-axis. And then we're going to translate it 4 to the right and 6 up. So here's 4 to the right and 6 up. 4 to the right, 1, 2, 3, 4. 6 up, 1, 2, 3, 4, 5, 6. So my final result is going to be right here. And that is x double prime, which is 5, 2. So x double prime is at 5, 2. All right, the next one, line JT has coordinates -1, -4, and 2, 3. So I'll do -1, -4, and 2, 3. Should say line segment JT has those coordinates. All right, so I drew my line segment in. Let me try that again. Let's get a little bit closer. Looks pretty good. All right, the segment is rotated about the origin 180 degrees. So let's see if J, so let's see what that would look like. We have x, y maps onto opposite x, opposite y. So J at -1, -4 would be at J prime, which is 1, 4. And then T, that's at 2, 3, would be at T prime, which is -2, 3. So now I have 1, 4, which is J prime, and T, which is -2, -3. So there's T prime. All right, so that was a rotation. And then it's translated 5 to the right and 3 units down. So translated 5 to the right. So let's see, I'm running out of colors here. So x comma y maps onto x plus 5, y minus 3. And that's going to be 1, 2, 3, 4, 5, 1, 2, 3, and 1, 2, 3, 4, 5, 1, 2, 3. Whoops. Okay, and what that is going to do is it's going to make j prime at 1, 4 go over to j double prime at 6, comma 1. And then t double prime, no, sorry, t prime at -2, -3 is going to move over to be a t double prime, which, 2, -2 plus 5, oh, sorry, 2 plus 5 is 3, and -3 minus 3 is -6. So the final coordinates are j double prime is at 6, 1, and t double prime is at 3, comma -6. What I should do for this one is I should write my reflection rule. So this is the answer. I really shouldn't be lazy. I should be writing out my rules. So for this one, it was a reflection across the x-axis. Sorry, x equals 0 or y-axis, which the rule is x comma y mapped onto opposite x comma same y. And so x went from -1, -4 to be x prime at +1, comma -4. And this should all be in a different color. And then this other one was a translation rule, x comma y mapped onto x plus 4, y plus 6. So x prime at 1 comma -4 ended up going to be at 5, ended up becoming x double prime at 5, comma 2. That was good for that one. Okay. The point 3, -2 is rotated 90 degrees. So let's put point 32. 3, -2 is right here. Okay. And it's rotated 90 degrees about the origin. So that's going to be, so it's at 3. So point is at 3, comma -2. And the rotation rule for 90 degrees is opposite y, comma x. So we're going to go p prime is going to be 2 comma 3. All right, so 2 comma 3. P prime is 2 comma 3. That really should be in purple then. All right, and then it says it's dilated by a scale factor of 4. What are the coordinates of the resulting image? So a dilation, and I can't even graph this one because the dilation is going to go this way. It's going to get dilated that way. But what I will do is I'll say the dilation is x comma y maps onto 4x comma 4y. So P prime is 2 comma 3, which will bring us to P double prime, which is 8 comma 12. So the answer is 8 comma 12. And there we are. So now this next one. What is the image of point A, which is at 4, 2? 4. A is at 4, 2. After translating 1 unit down and 1 unit left, here's a translation. 1 unit down, 1 unit. This is 1 to the left. This is 1 down. So we have 4 comma 2, which is going to be A prime, which is going to be 3 comma 1. Okay, so we are translating it 1 unit down and 1 unit to the left. We are rotating that 90 degrees. So again, we assume it's always counterclockwise. So that is opposite y comma x. So we're going to take A prime, which is at 3, 1, and rotate it to A double prime, which is negative 1 comma 3. Okay, and then reflect it across the line y equals x. So reflection across y equals x is is y comma x. So we have A double prime, which is negative 1 comma 3, and it's going to go on to A triple prime, which is 3 comma negative 1. So 3 comma negative 1 is A triple prime. And that is because of this line. Reflection across this line, y equals x. So the answer is A triple prime is 3 comma negative 1. All right. Next one, reflect ABC over the, maybe I should number these. This was 1 and 2. Oops. This was 1. This was 2. This was 1. This was 2. 1, 2, 3. Okay, 1, let's see, 1 is reflect ABC over the y-axis and then translate it. Okay, so ABC over the y-axis. That is the x. This is x equals 0, which means the x's are changing. So opposite x comma y. So A, B, and C. A is at 4. 1, 2, 3, 4, comma 1, 2, 3, 4. So 4, comma 4, right? 4, comma 4. B is at 2, comma 2, and C is at 2, 4, 6, comma 2. So 2, comma 2, and 6, comma 2. They are mapping onto opposite x, comma y. So we get -4, -2, and -6, 4, 2, 2. So -4, comma 4, -2, comma 2. That one's B prime. That's C. That's A prime. And C prime. And now it is, I don't like doing it. Let me redo these. Okay, here's your A, B, and C. So that was the first one. The second one is translate the image 8 units down. So don't really have much room, but let's see. X comma Y maps onto X minus 8. Nope. X stays the same, and it's just Y minus 8. So A prime is at -4, 4. B prime is at -2, 2. And C prime is at -6, 2. And it goes down 8. Yikes, I'm running out of room. I'm going to have to shrink this information right here. Does not like when I do that. Okay. Third time is the charm. Okay, we can move this just a little bit over. That should give me enough room. A double prime, B double prime, and C double prime. We're taking 8 away from the y, so -4, -4. We have -2, -6, and -6, -6. So -4, -4. Nope. So I'm just going to take this, copy, paste. We're going down 1, 2, 3, 4, 5, 6, 7, 8. Changing the style. Let's change it to blue. What I do know is this won't work. It's supposed to be -6, and then that's supposed to be C double prime. And there we are. So the final coordinates are A, B, and C, -4, -4, -2, -6, and -6, -6. There we go. All right. Last one before this final part. Okay. Triangle JKL has vertices 6, -1, K has 10, -2, and L has 5, -3. So 6, -1, 3, 6, -1, 10, -2, 2, 4, 6, 8, 10, 10, -2, and 5, -3, 2, 4, 5, -3. And that is JKL. So J, J, K, L. Okay, JKL. Graph JKL and its image after translation 4 units up and a reflection over the y-axis. Okay, so first thing I'm going to do is take translation 4 units up. So x comma y maps onto x and y plus 4. So first thing we do is slide up. So J, K, and L, 6, -1, 10, -2, 5, -3. It's going to go to J prime, K prime, L prime, which is add 4, so 6, 10, and 5, and 3, 2, and 1. 3, 2, and 1. So 6, 3. So what is it? 4 units up. Okay. 1, 2, 3, and 4. Let's make sure. 1, 2, 3, 4. Yeah, let's just make sure we're on. There we are. Oops, I don't know why I'm putting 2. It's only 1 tick mark. There's our JKL, 4 units up, and now a reflection over the y-axis. So y-axis is the line that is x equals 0. So the reflection is over the x. The x's will be changing. So that reflection is x comma y maps onto opposite x comma same y. So now all of these are my new ones. And they're going to map onto the opposite x's. So J double prime, K double prime, L double prime, -6, -10, -5, 3 stays the same, 2 stays the same, 1 stays the same. So I get 6, -3. Wait a minute. The y-axis, which was x equals 0. Okay, yes, so 6, -3. No, I'm sorry, -6, 3. So negative 2, 4, 6, 1, 2, 3 goes right there. And then we have negative 10, 2, which goes right there. And then L should be right here. That is negative 5, 1. Yep. So we have L double prime. We have J double prime. We have K double prime. And that's our answer for final coordinates. Huh, that's fine. So we did 1, 2, 3, 4. We did all the problems for this. So those are composites, right? And so now what you need to do, the only thing left for this unit is the semester 2 practice CCA. And when you're done with that, the only other one is the only other thing is the CCA. Now, for this example, write one set. I mean, we can do this in class, or you can get started on it at home, and then I'll look it over in class or whatever. But the last class period will be just the CCA practice and the CCA, unless you want to do the practice early. So I'm just going to explain each one. So in each example, write one set of transformation rules to help R2D2 join C3PO. If you're not sure, this one is R2D2 and this one is C3PO. So if you want R2D2, which is on this coordinate here, to join C3PO on this coordinate here, then you're going to have to write a combination of rules that will get him there. So we'll get them there. The set of rules must include two different types of transformations. So you're going to do, for instance, you might want to, I don't know, translate. You might want to rotate, maybe rotate and translate. So this is set 1. And then write one set. Okay. So yeah, which includes 2. So that's it for this. This next problem, you might want to, I don't know, set 1. You might want to reflect and then translate. That might be something you might want to do. Okay? And for this one, it says write 2 different sets. So one of them, you're probably gonna, I don't know, you might want to do, let's do this. Oops. I don't know what just happened. It was weird. So for these problems, you're going to need 2 different sets. So you might want to, and in this case, you're bringing, let's see. You might want to do a set where you reflect and translate, and another one that you rotate and translate. And so here you want 2 different sets with 2 different types of transformations. Okay, so they can't be translate, translate. It can't be rotate, rotate. It can be rotate, translate, reflect, translate. That would work. And now you're bringing Mario to join Princess Peach. So Mario, this one's Mario. Bring Mario over to Princess Peach. Okay? Again, these two, your setup will look like this. Okay? And you're going to write them all out, but I'm just giving you an example of what you would see. So this one is 2 different sets of transformation rules to help Ash capture the wild Pokemon, but you can't go, you got to stay out of the lakes. So your location can go anywhere. It just has to be 2 unique ones that gets the Pokeball over to Pikachu without, you might want to go here and then reflect, or you might want to go here and reflect over. You can go over them, you can go around them, or you can't go into them and stop in them. Okay, you can't go anywhere, so these are all off limits. Okay, same thing for that. This is Mewtwo. All right, there's Mewtwo. So this one is, yep. Let's see. Then this one, the captain of your ship wants you to bury a treasure chest full of gold coins. Part of this task involves making a treasure map so that your captain can find the treasure chest after you bury it. So you're going to move this all around. You want to go everywhere, wherever you can, and then make it, not too complicated, but make it, a reflection, a rotation, translation, mix them up. You want 4 transformations. Again, the easiest ones are to end with is a translation, just because it makes it easier. You can do any one of them, translation, reflection, or rotation. Don't forget to list the final coordinates. Okay, so it's up to you how you want to move it. You might want to reflect, then rotate, then translate. Maybe you want to reflect, rotate, translate. If you want to translate, reflect, rotate. It's totally up to you, but write them all out and then put your location in there. All right, so we're going to do this in class if you want, or you can take your CCA in class. But this you can do early or not. You can do it in class if you want, but it's part of this video. I figured I would include it. So that is it for the unit. Good luck.